As we know, the state of technology today is really, we hear about large language models, what's happening across the industry. We have almost every week groundbreaking technologies being released to be used for different applications. Technology leaders like Anthropic, Google, Facebook, Meta, and OpenAI, along with DeepMind, are really releasing a lot of tools available to the customers. And now we are really seeing this technology starting up to catch up with human reasoning and human intelligence. And really the way to differentiate across this technology and the set of tools available is we can really now today do an IQ test benchmark across different aspects of human reasoning, math, graduate, undergraduate level kind of intelligence. So now we have benchmarks available, but the real challenge is that this technology is how do we apply it to really real life problems and use cases, because they have been really designed for three things: models, proprietary data sets, and unlimited access to compute. And that's where we are now seeing that shift from machine learning to machine intelligence, where machine learning was really focused on analyzing and processing data sets around statistical analysis, doing other kind of inferences, which allows us to make some decisions. But now we are moving to intelligence, which allows not only to derive those inference, but also convert that into actions and agents and automate the whole end-to-end process. And then in this journey of building this intelligent machines and models, we are starting to see things like hallucinations. And that really is indicating that machines are doing things which we don't understand today because it has a black box effect. But the challenge really is that, as you would have seen, that along with big models and big data sets, we are requiring huge compute. But that is not how nature has intended us humans to think, yeah? Because let's say if we needed unlimited energy, unlimited resources to analyze and think and take decisions, we would probably eating more than thinking. Yeah, that's not how human brain has evolved. And that's where we are seeing now the next wave or the next generation of really taking this technology innovations and converting or converging our digital brain with biological brain. Because the large language models and generative AI, they are very important, but they solve a specific function in human brain, which is really speech and language. But then as we build agents, as we apply this technology across different business functions, across different industries, we really need to start thinking about other capabilities as nature has evolved. And that's where we see now a new field of science now emerging and becoming a forefront today, which is computational neuroscience, where we would be applying all the technology that we have built, but now aligning it to how really nature has evolved human brains. And that's where, when we apply this to, let's say, investing industry, yeah, how we are really seeing these use cases, we see some interesting applications. And as we move into the future, we see really this agents and this automation getting applied to two fronts. One is, let's say, the wealth advisors, where we really kind of start looking at how do we apply this capabilities in providing fantastic user experience to our customers across the life cycle, from advisory to, let's say, regulatory and back office functions. At the same time, we have wealth machines, which really are evolution of how we have built and kind of created technology around quantitative investing, around trade executions, and other functions in the capital markets industry. But the key breakthrough here is that how do they converge? And what we see happening as we go forward, we anticipate that the regulations in the future in the AI industry will require any agents in the future to really do certifications. So all the agents in the future would have to go through the same certification process as humans. So for example, any wealth advisor agents will have to go through CFA certifications, the wealth machine will have to go through CTA certifications, and so on. So it's very important how we build this architecture and technology, because really we are now evolving at the same time the capabilities not only to do inference and intelligence, but also act in this market. So if we see across other industries like self-driving cars, healthcare industry, capital markets, we really see now in the future we will have regulation which will require the machines to go through that certification process. So it's very important as we engineer and design and we apply this technology, we start applying the same standards to these machines just like humans are required, yeah? So that's a very interesting kind of, I would say, innovation we are seeing right now. So we are building machines today around capital markets use cases, but they are built in such a way that they can go through that same certification processes. So today the technology allows us to build those layers of really innovating and building this going forward. Also, now the way we see it is that the digital mind, it's not only just one thought process, as we saw, like the human brain has to do a lot of functions. So it's really a combination of a master algorithm which the nature has evolved us humans in, I would say, probably the best machine that we know in the universe, which is our brain. And that's where we see we are combining these applications not only to large language models, but also what we call it as causal graphs. And we have some talks further during the day with some of our other partners here. We'll be talking about how we really can enhance the reasoning and the truth grounding in these technologies. So for example, we combine causal graphs, which really focuses on memory, time series, reasoning, and evolve that with natural language models, which we hear a lot today from the companies like OpenAI and Anthropic and Google. And that allows us to build a technology which is really explainable. Because yes, we have some fantastic machines, we have some fantastic capabilities, but at the same time, it is very crucial for us that it doesn't have a black box effect, because the biggest challenges that we see in the industry and application of AI today is the size makes it very complex, and then it becomes very difficult to understand what kind of actions these machines can take. So really, to build this natural layer of human to machine interaction, we are seeing convergence of these technologies into what we call it as a master algorithm. And that is very important as we start working as business and technology together. When we ask, okay, what is the best way to apply and really leverage the automation and AI that we have today, we really have to also see that language is different from intelligence. So that's where we are seeing this new evolution of really combining multiple capabilities of what we know and converging into a master algorithm, which will really help us to evolve the machines of the future. And that's where, as we build this architecture, we start seeing a very distinct layer of how human mind has been built. So in the future, when we talk about, let's say, market data, historical performance, when we start talking about market patterns, risk management, it can really be divided into a very similar structure how human brain is designed. So we have sensory blocks where we look at all the live market data, performance analysis, and so on. Then in the perception block, we do all the market memory, all the pattern matching. Then we build our trade experience and investing experience there. And then the planning block and the action block, where planning block takes care about the risk management, and the action block talks about executions. So this is how we are building the architectures of the future. And then as we apply this to different layers across from front office to back office in different applications, it really becomes interesting how they align and how they interact with each other. So that's where we have seen the evolution from traditional models today to AI platforms, AI teams, and a team of experts in the future. And then it evolves into the AI thinking framework, where we have a kind of a rule. Yeah, it's a six set of rules, 6 variables, where we really look at not only building the machines, but also optimizing the whole process. Because the biggest challenge right now in applying AI and automation to the use cases is really what I call it as the cost of decision. Yeah, because yes, it has its complexity, it has its I would say challenges around training, around access to compute. So what we have done is we have simplified the process so that we can really focus on the behavior aspect of the technology, like the repetition, the prediction, the planning. But at the same time, we also look at the amount of data it needs to compute and to derive intelligence. And that's where we have a bit of a contrarian view that large data sets, yes, they are interesting, but we really need to focus on what is really important, what is the information that we need. So we are really looking at the 1% rule, is that most of the times, and just how human brain processes and consumes information, it really just looks at less than 1% of information that we actually consume every day, and really what is important. So there is a real natural filter that we have built in to optimize the whole process. And then how do we explain the decisions taken by the machines? How do we measure the intelligence? Yeah, because traditionally how we have been measuring automation in terms of productivity and repetition versus, let's say, machine learning through basic parameters like accuracy and recall, we now really have to look at, as I said, whether we can certify and talk to the intelligent machines and we can interact with them. And what is the cost of decision? And the most interesting thing that we are seeing now is whether a machine can solve more than one problem. So very happy to share that. And just it's a very simple kind of a use case where today, it's just an example, and we can talk more over the next couple of days with our team here as to how we are taking this and applying it and combining this technology and applying it to real life opportunities in the markets and the use cases. Yeah. And then the future of intelligent agents. So this is something which is groundbreaking, which our team is working as of today. What we call it as one brain, multiple minds. Yeah. And if we really compare, like, yes, a car can always move faster than a man. Yeah. So if I want to go from point A to point B, a car will always take me faster. Yeah. If the distance are longer, then of course a plane will be faster than a car. But it's interesting is that it's only designed for one specific function. However, as we see the technology evolving, we see this concept of one brain, multiple minds, where we can solve a specific machine will do more than one function. If I take my example, yeah, I can write code, take investing decisions, play games, drive a car. So what we are seeing is that as we apply artificial intelligence and the future of agents, we would have agents performing more than one function. That is how we can really optimize our investment in these technologies, because today, the other challenge besides being the size and the scale is we are creating one machine for every problem, we are designing a different machine. And that is what is really creating a challenge in scaling up, because we end up in an organization with 200, 300 different models, and that is not sustainable. So that is where we are now working to see how we can build one stack where we can start building machines, just like how the nature has intended to do. Yeah, so it's a very interesting kind of, I would say, evolution and innovation in the technology which our team is working on. And then to build these agents, to build this technology, we really need an intelligent software factory. How we can build and apply and work together with business teams to really build this at scale and apply this in a standardized way. So that's where GFT has a very, I would say, a structured model for developing software. How we write and develop software, how we write and build solutions is changing. I have been in this industry for like 28 years now, and the way I used to write code maybe 28 years ago has changed. The way I used to write code 2 years ago has changed. Yeah, so it's constantly evolving, and now we have practically co-pilots engaging in developing code across the different life cycle of this development process. But it's not only about software development, yeah? It's not only about that, it's also the other components around it. So for example, how do I capture my user stories and user experience? How do I monitor and manage my platforms? So that is where we have built a set of tools which really allows us to apply the technology in the software factory model, which allows us to build agents which can be intelligent and which can be automated based on the innovations that we are seeing. And then it takes us to the benefits of it. So for example, today we see benefits in the process of development software and full life cycle, anywhere from 30% to 70%, yeah, from development to monitoring to fixing issues, which is interesting. And that's where our team today here, the GFT team is here, over here. So I would invite you to talk to our team. So just if the team can just say hello to everybody. Yeah. So we are here. And really our focus is on three things. Our core team of experts are focusing on really how to apply these innovations to the business and how we can create value which can align to your culture and your business objectives and create the impact. Then we can co-create some of the interesting use cases you might have. With our experience and the research that we have done, we can really work together with you. And then at the same time, we already have a set of tools which can accelerate the processes that we have as we go forward. Yeah. So thanks a lot and have a great event for the next 2 days. We'll definitely talk more about business, about technology, and of course, we'll hear a lot about artificial intelligence. Thank you.
The program will resume in 5 minutes.
Thank you, Rana.
You're sweet.
Kelly.
Thank you so much.
Thank
you
you.
were great. Really
Thank you.
appreciate it.
Great job.
If you
Thank
come
you
right back
very
over
much.
to John, he'll take off the microphone for you.
Thank you.
Thank you.
Thank you so much. Was it
Very
okay?
welcome.
Yeah?
It was great.
Sorry. Okay.
So great. Awesome. And then I'll just take this. Oh, is it caught up enough?
I'll wait. Thank you so much.
Got it. Thank you.
Thank you.